there, happy learner, and welcome to a math tutorial video. And in this video, we're going to learn about exponents and logarithms. So let's just take the time to listen, sit back, and learn and enjoy the show. Okay, so first things first. So, moving on to the preliminary section, I have listed a bunch of beautiful examples that show us the way exponents work. Now, think of this way. If you have 3 plus 3 plus 3, essentially you're counting out the number of 3's, and you're using the number of 3's right here as a multiplier that gets all the 3's up to 9. This example translates to 3 times 3. Like, if you, like, for instance, if you have, like, let's say 5 5's, you're gonna get 25. That also translates to, 1, like 5 times 5. And as for division, it's kind of like similar, but except you're essentially subtracting the whole number by a number of 4's. So, first off, we have a 12 over here, and second off, we have like a number of 4's here, which also add up to like 12. But here's the fun fact. Like, all the 4's represent how many times you subtract by 4 in order to get 0. So, like, if any, so if a number that you're trying to divide equates to 0, okay, so like if a number that you're trying to divide equals 0 based on the divisor that you're subtracting the number with, that is a perfect divisor for a number that you can use for whatever number you're trying to divide. But what if we do the same thing with multiplication? Well, that's the only thing we're going to fully discuss right now. So moving on to the next slide. So what are exponents actually? Well, they are the teeny weeny numbers you see on the top right corner of a number. They actually tell you how many times the same number multiplies by itself. Like, let's say like 1 times 1 times 1, or 2 times 2 times 2, or something like that. But we're gonna see the way it works on the next slide. So right here, I also listed some wonderful examples that will help you see that will let you see the way exponents work. So here I have 34 to the power of 3, or 34 cubed. So like the 3 over there represents the number of 34's that are multiplied by each other, whereas 5 to the power of 2, or 5 times 5, or that's like 2 5's that's like 2 5's multiplied by each other. And for cubed, oh, there is a typo over there. Yeah, my apologies, but I'll fix it. Alright, how better? So here you have 4 4's multiplied by each other. That equals to 64. And this number here again represents the count of the same number numbers that multiply by each other. And what about this number? Like, yeah, like imagine trying to multiply all that at once. Like, it's not gonna be worth it unless you're an expert mathematician who knows which number is bigger. Like, as for exponents, if you if you really want to find whichever number's degree is, like if you're trying to compare let's say 2 to the power of 100 to 3 to the power of 50, then that is the only way to put it together. So moving on to the next slide. Moving on to the next slide. So there are lots of interesting stuff to talk about. So let's just schmooze about something really fascinating about our particular topic that we're discussing. So interestingly, okay, now I'll think of it this way, like if you're working on if you're working on an ordinary math equation, like whether it's like addition, subtraction, or multiplication or division, whether it's whether it's addition, subtraction, or division or multiplication, it doesn't make it doesn't even make that much of a difference. So right here, we have an right here we have an addition equation right here with with each of them having their brackets um resorted, reassorted. I mean, but as for as for multiplication, if we take a look at this, if you take a look at this, they actually mean the same thing, even if you swap the numbers together, right? But as for exponents, it isn't actually true. Like the output actually like the the output actually is dictated by whatever however you define the equation, like whether it's 2 to the power of 2 to the power of 3 or whatever. Yeah, like the output actually is like the output is actually dictated by how you define the question, whether it's 2 to the power of 3 as in like multiplying it, or 2 to the power of 2 to the power of 3. That's exactly going to show you the way how it's defined. Now take 10 to the power of 10 to the power of 10, for example. Like if you divide it as 10 to the power of 10 to the power of 10, as in like multiplying those tens together, you're gonna get a Google right here, or in simple terms, 10 to the power of 100. But if you only raise an exponent to a power, if you only raise an exponent to a power, the number right over here will be an astronomically a large number. So yeah, like unless you're an expert mental calculator, you most likely know how big is a number it is. Now there are lots of interesting stuff that I can there are lots of interesting stuff that are yet to be talked about. So exponents do not only apply to numbers; they also apply to variables too, which is interesting. Because think of how you saw those teeny weeny numbers on top of a letter. You're gonna see stuff like x squared, x cubed. You're gonna see stuff like this in high school. And also, and also, and right here, this is where we are now talking about logarithms. So when trying to find the exponent of a number based on the base number, the methodology that helps us with that is called a logarithm, which is essentially the inverse of an exponential expression. So for example, 2 to the power of 2 equals 4 equates to logarithm base 2, and this number is 4, and that equals to 2. So what logarithms actually do is fetch the exponent of a number you're trying to find based on the number that you input in the big number section, or whatever it's called. So, and also, when you multiply two numbers with exponents, you're only adding up the exponents together. And also, I was thinking of multiplying two numbers with the same base number but different exponents. You're only adding up the exponents together. So, if you'd like to take a look at um, when I just stay here, you can pause here for a moment. Like, it's all addition and subtraction right here, but only on exponents. And uh, and there are a bunch of beautiful logarithm formulas right here. Oh, why do we just do examples? Oh, actually, why do we just do examples on that one first? Okay, let me just create a new file and open up my screen sharing thing. Okay, so I'm on my iPad right now, so I'm gonna show you the way to do it. So I'll show you how you, yeah, I'm gonna show you how to do it. So let's say you have 3 to the power of 6 times 3 to the power of 3. So, wait, let me just get this out of the way. So, 3 to the power of 6 times 3 to the power of 3. So, we have two exponents that we can add up. So, 6 plus 3, that's 3 to the power of 12. So, to prove that, we're going to use our calculator. So, let's go ahead and find my calculator first. Okay, so if you go on your calculator, okay, so like if you go on your calculator, and you put in 3 to the power of 12, you're gonna get a 531 But if you do, but if you multiply these two out directly, you should get the same answer. Like that should be adding, not that should be adding, not multiplying. My apologies. And yep, you're gonna get the same answer. But what about dividing? So, but what about dividing? So, let's say, okay, so like we're gonna do the same, yeah, like we're gonna put up the same numbers, but this time we are going to use division. So 3 to the power 6 divided by 3 to the power 3. So when you're defining when you're defining two numbers, yeah, like when you're defining two numbers of the same number but the different exponents, you're only subtracting the exponents. So 3 to the power 6. So 6 minus 3. Oh wait, sorry. Let me open it up. So yeah, 6 minus 3. That's 3 to the power of 3. So do that in your calculator. Oh wait. Okay, so let me just. Alright, just give me a moment. 729 divided by 27. That should give you the same answer. And yep. And now we're all done with this part. Okay, so I have made a nice list of beautiful logarithm formulas that you might have seen or will see in high school. So if you like to take a if you like to take a moment to have a look at them and how it works, if you would like to take a moment to have a look at them and how they work, pause the video for a moment, like, and also I have listed example questions right here, so you can actually I would say the way they work, and there we go. That wraps up the story. So, yep, that's it for the video, and thank you for watching this beautiful math tutorial video, and hope you really enjoyed it, and I will see you in the next one. Take care.